Okay, Assalamu alaikum, Shema. Welcome back to the class. I hope last Thursday everybody went ahead and listened to the lecture, the one that I posted for you. So if you already saw that lecture, you should be more than fine today, because today I will have to solve this problem, and hopefully I can solve also another one using Castellano theory. And if you did not watch the lecture, you will be probably in big trouble. You will not understand anything. However, I am going to try my best to cover you up. So this problem says that if you have a simply supported beam like this one, with two concentrated forces, both equal in magnitude, acting downward, and we want to know the maximum deflection. It is assumed that E, the modulus of elasticity, and I, the moment of inertia, are constant. And if you recall from my past lecture, what did I say? I said that if you want to find the maximum deflection, by inspection, you can expect that the maximum deflection will be in the middle buoyant, since the beam will curve like this due to the action of the two forces. Now, so what happened? But Castellano theory says if you want to find the deflection, you need to find the total strain energy density in the body. The strain energy in the entire body here, the body will have strain energy. Go and find it. Assume that you quantified this blue color in the beam, and then go and take the, of course, when we quantify the strain energy, we don't find it as a number, we find it as a in terms of relation. So, and then what he said, go ahead and take to find this deflection, you need to take a derivative with respect to a force which is also acting in the same direction of the deflection and at the same point. Now, clearly, there is no force over here. So what should we do? We put a fictitious force, يعني imaginary force which has a value equals to 0, just to trick the equations. Form the equation and then put Q equals to 0, and that's it. So let's see how are we going to do this. Now, I want you to remember, if you don't, if you have a, if you don't have a kind of a strong memory, you may want to have a piece of paper and you sketch the drawing, because I will have to go through too many steps and I cannot keep blotting the figure again and again. You understand? So let me start by plotting some sort of a free body diagram. So I'm going to call point A over here, point B, and then C, and then D, and then E. Please don't confuse E as a buoyant with E as a modulus of elasticity. I have a reaction, I'm going to call it reaction 1, and a reaction 2, I'm going to call it R2. The length in between is L, or maybe you will confuse this, so it is L. And what I know is that there are forces, force 1 P, which is at a distance equals to A, and another force P at a distance equals to A, and then finally I have Q. That's a complete free body diagram. Now, if I want to to solve this problem, the first thing I need to do is to find the reaction forces. So from symmetry, because of symmetry, the whole problem is symmetric, somebody can understand that R1 plus R2 is actually going to be, let me tell you, is actually what I want to try to say here. From symmetry, somebody will reasonably understand that reaction 1 will be equal to reaction 2 will be equal to R. I'm going to call it R. يعني in simple يا شباب, in a simple way, the two reaction will carry B plus B over 2. You understand each reaction. So if I sum up the forces along Y and say this is equals to 0, taking up as positive, then I will have two reactions, okay, minus Q, right? Just wait a second. Let me look at the solution over here. Yes, Ali, you want anything? I think there is something wrong in the solution. Anyway, so I will have two reactions upward minus Q, which is the force, okay, minus 2P equals to 0. Is that correct, ya shabab? Is that correct?
Yes.
So what would I get from here? I will get that
the 2B, Doctor.
What?
Plus 2B.
But B,
okay,
2B downward,
okay.
صح? So the reaction will be equal to Q over 2 plus P. That's the reaction. This is the... What?
If we consider the Q will be 0, so R will be equal to B.
Yeah, but be careful. The trick that I told you is you need to wait for the right moment when to substitute Q. إذا يا شباب حطيت Q من البداية, حطيت سهم وسميته Q وقلت هذا equals to 0, بعدين سويت 0, وش سويت؟ خلاص. So why are we laughing at يعني the trick is this: you will build the entire relations with respect to Q, and you will see later that when we substitute Q equals to 0, the whole thing is not going to go to 0. That's the beautiful thing. So just wait for some times and you will see. Now, so what are we going to do right now? We are going to start by cutting the first piece of the beam. So the first piece of the beam, which is this one, I will have a reaction, right? And this is point A. And then there, I will have a shear force. And then a moment. So what I'm going to do, I'm going to call this one VAB and this one MAB. لأنه this is what's going on inside the beam. The distance from here to there is X, and I know that X is less than or equals to A and greater than or equals to 0. Why is that? Because I want to know what's happening until over here, just before point P, the force P. This is what you have been taught in CE 203. So if I am interested in the moment, so what I am going to do, I would go and take the moment where, ya shabab?
What A?
Should I take the moment at A or should I take it right here? If I take it at A, V, the shear force, will cause a moment
And
and I will be in trouble.
yes.
And I don't want it. So I need to take the moment at the end. And by doing so, what's going to happen? I will have MAB. Look, MAB is rotating this way and R is rotating this way. Do you understand that?
Yeah.
So both of them are opposite to each other, which means that MBAB is equal to R multiplied by what?
X.
Multiplied by
X.
X. Now, what is R? R is Q over 2 plus P, and then this is X. So if I want to write this in a better, complete form, I can write MAB as a function of X is equal to X multiplied by Q over 2 plus P. Now, this is the first equation that I got, okay? And don't forget that for this equation, X is less than A and greater than 0. Understood? Now, what are we going to do? We're going to go to the next one. The next one, we will take the reaction the same, but then we have to consider P. Now, and what is after P? So here, this is A, the distance. This is point A capital. This is point B capital. And this is where we cut the beam. Now, when we cut the beam, I'm going to call this one VBC and this one MBC, which is between B and C. Okay? Now, you have to be very careful. There, we will call this one X. But we want X to be greater than or equals to A and less than L over 2. Why is that? Why is that? Now, I want to take the beam up to here. I don't want to consider Q, so just before that, but I want it also not to consider this part, because this part, I already covered it here. Do you see that? I want what is happening in here. That's why I should take it after A, but less than L over 2. Do you understand that, ya shabab?
Yeah.
Okay. So if I do this, look what will happen. Look what will happen. I will take the moment again at this point, which is the end, to get rid of the shear force. And now I will get this relation, which is MBCX, okay, which is equal to what? The reaction B plus Q over 2X, and then minus P. ليه يا شباب؟ لأنه this one now is rotating this way, while this one is rotating this way. So both of them are going in the same direction. Sorry, I should talk the moment. I should, no. Yes, I am taking the moment with respect to this one is going this way, صح? While this one is going this way. So they are opposite, okay? It's with respect to this point. So minus P, which is the force, multiplied by, now what is the location of point P, the force P, ya shabab?
L over
It
2
is at
minus
a
A.
distance X. It's at the distance X, but always minus A. ليه؟ لأنه هي بعد ال A. So I can ما دام ال X من هنا يبدأ، أنا شو أسوي؟ أقول له دائما أي قيمة X minus A. You understand that? So this is going to be X minus A, and then the whole thing will be equal to this. I will have QX over 2 plus PA. Can you wait, Shabab? Just wait a second. Yes. Okay, so we got the equation for M between B and C. However, you should also remember that this equation is valid for X, which is less than L over 2 and greater than A, less than or equal or greater than or equal to A. Now, the next segment is to consider the beam after point the force Q. So again, here I have the reaction. The reaction in the solution, you will see it. I'm writing it R equal R1, which is the same as R over here. So in there, we have the force P, and then we have the, what is it? The Q, okay? So this is the point. And again, I will have a shear force, which I am going to call VCD, and a moment, which is called MCD, because it's between C and D. And I should remember that this is A. I am still taking X from here. So in this case, you need to be very careful not to make a mistake, because the equation is not getting difficult. It's just adding more terms. It's getting bigger. So MCD X, which is equal to P plus Q over 2 X. Look, this is similar to this part. You will see this part is going to come again. It makes sense, right? And what happened, you will have minus P X minus A, and then minus Q multiplied by X minus L over 2. That's it. The only new part is a Q, and a Q is active, it start acting after a length, any length X minus L over 2. You understand that? So
Yes.
if you say that this is going to be Q L over 2 minus X over 2 plus PA. This is the simplification of the equation. You will have this one between X, which is less than or equal L minus A. L minus A, because I'm saying here that it is valid until this point. So it is any length L. However, I don't want to include this. That's why I'm subtracting A. And maybe this symmetry sometimes causes problem with the طلاب شوية, maybe they get confused which A, so I want you to understand that this is this A. Okay, now so let me go back to the solution. So, and this one is X is greater than L over 2. Now I need to do the last one, which is this is a heavy meal, ya shabab, huh? I brought you something that when you know it, khalas, you are done. And I know many students don't like this. And it is not that I don't want to do what you like. It's because I cannot solve 10 million problems for you. So I need to pick you one good problem or two problems which can teach you everything I think you have to learn. So this is a Q, and this is B. So this is point B, this is C, this is point D. Okay, so the shear force is here. This is V, and I'm gonna call it DE, between D and E, and this is moment DE. Same business again. Okay, X start from here. So this time I need to make a big space for myself. M D E X is equal to same part as before, but this time I will have to add the last one. So I will have P plus Q over 2x minus Px minus A, and then minus Q x minus L over 2, and then the new part, which is P multiplied by x minus L minus A. So any distance x which exclude the last segment, which is L over A. The last segment is L over A. Do you understand that? So this is going to be equal to Q multiplied by L over 2 minus X over 2 plus P multiplied by L minus X. And this is in between X, which is less than or equals to L, and greater than or equals to L minus A. Okay? Now, what should we do? I know it is very hard to go back to the equation, but let me show you very quickly. The first one now, I need to take the moment of this one, dm abx, with respect to q. And then what would I get? I will get this as what, ya shabab? Look carefully. If you multiply this, if you look at this equation, you will get x q over 2 plus x p. صح ولا لا?
Yes.
So if you take the derivative of this one with respect to q, the only part that has a q is this one. صح؟ فشو اللي يطلع معي؟ x over 2. Is that right? So I will get from this x over 2. I go to the next equation over here, and I will get d del mbc over del q, which is again x over 2. Only this part. Now, if I go to the next equation, what would I see? I will see that I will have this part coming, and or this is it. Only this one. So del mcd over del q is equal to L over 2 minus x over 2. I go to the third one, and I will see that the same part is coming. So del mde over del q is equal to L over 2 minus x over 2. You understand that?
Yeah.
Now, what is next is the following. The next is this, that delta, as per Castigliano says, that find the strain, the derivative of the total strain energy density over Q. So, since I have equation, okay, I have an equation for each part of the beam. Now, what will happen is this. I know, ya shabab, that from the equation, if you remember, for bending, the strain energy is equal to what? Let me get that equation. I don't want to write it wrong. Let me write down the equation for the deflection from bending. So the deflection I from bending equals to the partial derivative of the total strain energy density with any force Fi, which is equal to the integral of 1 over EI, okay, multiplied by the moment, then the derivative of the moment with that force, dx. Do you see this? So if I have this equation, then what I'm gonna do, I will show you what I'm gonna do. I will say that I need to integrate from 0 to a, okay, for MAB, okay, divided by EI. You see, why is this? I'm just rewriting it. This is EI, this is M, and then I will multiply it by this. Good? So I will have del MAB over del Q. Then what? dx. صح ولا لا? And then I will have plus sign the integral from A to L over 2 for MBC divided by EI multiplied by del MBC over del Q dx. And then plus the integral from L over 2 to L minus A, okay, for MCD divided by EI, and then del MCD over del Q dx. And finally, the integral from L minus A to L for MDE over EI, and then I will have del DE over del Q dx. So what are we going to do right now? We are going to go to the equations over here. I'm not going to write this down, shabab. It's too much. It will just take the entire lecture. What is the equation of M? This is the equation of M. What is the derivative? This is the derivative. So as an example, for the first term, which is this one, I will have, look, I will have the integral from 0 to A for the equation was P plus Q over 2, okay, multiplied by X, and then I have X over 2 as a derivative, and then dx. Do you get that? Now, this is the point. Then you add the integral from 0 to A. Then you put the moment, of course, in here, ya shabab, طبعا, I want to tell you something. So to make it easy for you, just have EI as a common factor, since it is in the denominator always, and multiply it by delta. So you take it on the left-hand side. Now, you will write down the rest, but before you do the integration, substitute Q equals to 0. At this point, انتبهوا يا شباب, if you put a Q here, it will just make the equation so messy. Why? Because there are parts, like for example, QX over 2 plus BA. You don't need to deal with this. You don't need to integrate with X with this one. So what should you do? Just put a Q equals to 0. The integral size will drop down. And then integrate with respect to X. الانتجريشن يا شباب مرة سهل. عندك X صار X square over 2. You have a constant, you have X, and that's it. It's a definite integral. You don't need to put constant. You don't need to do anything. Now, if you do this, you will get an equation. Okay, I am going to write down the equation in the end, which is the following. You will have delta, which is equal to A multiplied by P. Then this is multiplied by 3L square minus 4A square divided by 24EI. Now, one little nice trick. If you go back to the solution number 9 in the appendix for for a simply supported beam like this, under two forces, okay, you will find that y maximum, I am copying the equation from the end of the book, okay? The y maximum, a ready solution, is FA over 24 EI multiplied by 4A square minus 3L square. So, what is the story over here? Very simple. P is the F, A is the same A, this is the same. The only difference is we have 4A square, and here we have 3L, and this is 3L. The reason why we have this is because Y maximum in this is measured as positive value. You know? But in reality, if you multiply this by negative, this is going to be negative, and this is going to be positive, which is going to be exactly like this, indicating that delta is negative as down. Do you understand? الجواب اللي موجود في نهاية الكتاب y maximum is for a delta يعني الماجنتيود هذا حينزل بمقدار 10 بينما السولوشن اللي احنا طلعناه هنا هذا يقول لك this is going below the zero by delta. Yes. أحمد. أحمد غزالي تفضل. No. Okay. So there is too many slides for the detailed solution for this.
Problem with the microphone.
تفضل.
This equation you wrote on the last slide only works with the symmetrical 4-point bending. Is that right? The last
What?
one. Can you go to the back? The last slide. This equation
This one?
only work with the symmetrical 4-point bending. Is that right? When we have
Yes.
two reactions and two forces at the same distance.
Yes.
Okay.
Yes. You want a more general solution where P is at a distance A, and the other point, the other force P is at a distance P, or the two forces P are P1 and P2. You need to work out the problem.
Okay.
It's just gonna get bigger and bigger. لأنه الرياكشن الآن ما راح تكون symmetric وما راح تكون عندها قيمة half of the two. But if you like the math, you go do it. If you think this is, let's assume you are a company, you design a product which require that equation. You bring an engineer or a mathematician or whoever, and he does the math for you once in a lifetime, and then you keep using the equation again and again and again. Maybe. Yeah. Okay. Now, the last part that I want to tell you is how to use Castigliano theory to solve indeterminate problem. What are indeterminate problems? Like this one. This problem, if you look at it, just look at it without doing too much work. This is a fixed joint, and this is a fixed end, I mean. So it is double cantilevered beam. When it is double cantilevered beam, each reaction should be replaced with each end or boundary condition should be replaced with a reaction force and a reaction moment. Now, if you look carefully over here, we have RC, MC, RA, MA. How many unknowns? 4 unknowns. How many equations do we have? Well, summation of x, f along x doesn't work. Why? There is nothing happening at x direction. So it gives you nothing. So you have only summation of the forces along y equals to 0 and summation of moment at point مثلا A is equals to 0. But these two equations will still have 3 unknowns. You understand? You will not be able to solve the problem. Even if you take them, this equation will have RA and RC, that's 2 unknowns. This equation, even if you take the moment right here at A, you will not, A will not make a moment, but you will have MA, RA multiplied by the distance, and MC. So this problem is not solvable. In civil engineering, they told you that we need to use deflection in order to solve it. Deflection will give you the third relation. Okay, so here it is not very much different. We are going to use Castigliano theory to solve the problem. So let me show you how are we going to solve it. Same problem. Okay, same problem. So if we want to use Castigliano theory to use, and this is one of the uses, advantages of Castigliano theory. So what are we going to do? We will start by cutting the beam somewhere within the distributed load, and then we will cut the beam here. Okay, so I will cut the beam right here. This is now part of the distributed load. I know that there is a reaction in RA. I know that there will be a shear force, which I am going to call V1x. This is distance x. And I am going to call this moment M1x. 1 means my first cut. Now, I also know that there is a reaction MA because it's a fixed end. So what is going to be this force? This distance is x. If this distance is x, then this distribution is W0 multiplied by x, right? And then this the distance from here to there is x over 2. Is that right? So let me now tell you how are we gonna solve this problem. If I sum the moment at point A and I say that this is equals to 0, then I will have M1x, which is going in a counterclockwise fashion. Of course, where did I take the moment? At point A. I didn't show you point A, right? Point A is right here. That's point A. Okay, so I have MA going counterclockwise. I have M1, MA going clockwise. RA multiplied by X is also going clockwise, but this one is going counterclockwise. So if I write down the equation, it will be like this. If I take counterclockwise as positive, then I will have M1A plus the resultant force from the distributed load, which is W0x multiplied by what? X over 2. It's distance, that's the force by distance, minus MA minus RA multiplied by X is equals to 0, which means that M1X is equal to MA, right, minus RAX plus minus W0 x squared over 2. And this is my first equation. Good. Now, what I'm going to do, I'm going to take the moment. I'm done with this. Oh, sorry, Shabab. So what I'm going to do next, I'm going to take the next cut. The next cut is like this. So I write down, I plot the distributed load completely. I have the reaction RA again. And now I have V2x, M2x, and this point now is point B. This is equals to W0 multiplied by A. Why? Because the distance here is A. Good? And half of it is A over 2. So this one I also have MA, the same reaction. Okay? Good, ya shabab. Of course, this is X. So if I now, for the second beam, I take counterclockwise and I sum the moment at point P. Again, like here, this point, to get rid of the shear force. So in short, I will get M2x, which is equal to MA plus RAX minus W0A multiplied by X minus A over 2. This is the force multiplied by the distance. The distance is any X minus this part, which is A over 2. You got that? That's why we have this. Now, what is new over here? Listen to me carefully. We will assume that RA is what we call it the redundant reaction. What does that mean? It means that I will go and apply Castigliano as the following, where del U over del RA is equals to 0. Why? Now, احنا تعودنا يا شباب بأن احنا نقول انه المعادلة delta equals to del U over del R something, right? But at A over here, the deflection is 0. صح ولا لا؟ ثابتة هذه ما تتحرك. Are you with me?
صحيح.
So now what is the consequence of this is the following. المعادلة, all of a sudden this delta equal to the integral of 1 over EI M del M over del F dx. ايش راح يصير فيها؟ إذا كان هذا 0 معناها أنا أضرب هذا في EI ويصير 0 صح؟ I get rid of this. And I end up with 0 equal the integral of M del M over del F dx. Correct يا شباب?
صحيح.
So what will happen? I will integrate from 0 to A for M1 del M1 over del RA dx plus the integral from 0 to L for M2 del M2 over del RA which is equals to 0. ايش سوينا؟ أخذنا الدerivative for the equation of the bending moment equation for the entire beam, which consists of M1 and M2, and I took the derivative with RA. So I go back to the equation and I look. In this one, I have RA. And in this one also, I have RA. So the derivative is not going to go to 0. So look carefully what will happen. Okay. Here, what would I do? I will have this one equals to 0 to A multiplied by MA, if you remember the equation, plus RAX minus W0 x squared over 2. And then the derivative of this. What is the derivative of this one with respect to RA? It's X. The only part that has RA is X, so I will have X multiplied by dx plus the integral from A to L for the second one, which is MA plus RAX minus W0A multiplied by X minus A over 2 dx. I forgot to multiply by X, ya shabab. Why? Because again, this one has RA. If I take the derivative with respect to it, I will get X, then dx. طيب خلاص خلصنا. إيش اللي راح يصير؟ When you do the integration, يا شباب, here you multiply by X and then you integrate. What will happen? You substitute for X equals to 0 and X equals to A. Here you substitute for X equals to A and X equals to L. And when you do the substitution, this is what you are going to get. You're going to get MA multiplied by L square over 2 plus RA multiplied by L cube over 3, which is equal to W0 A square divided by 24 minus W0 A square L square over 4 plus W0 AL cube over 3. That's equation number 1. Now look at this equation, Shabab. I want you to look carefully. This equation is function of L, which we know, W we know, A we know. خلصنا. البقية the same. This one is unknown and this one is unknown. So you got one extra equation which relate MA and RA. Do you know what are we going to do next? We are going to take MA as redundant reaction. What does that mean? We repeat the same step, but we take the derivative with respect to MA, which is equals to 0. Why? Because when you take a derivative with respect to a moment, you expect to get the slope. Delta will be slope. Again, the slope is equals to 0. Because for a fixed end, the deformation is going to go like this. And the slope for a straight line is 0. So what are we going to do? The following. We're going to have the integral from 0 to A for M1 del M1 over del MA dx plus the integral from 0 to L for M2 then del M2 over del MA dx, which is equals to 0. You repeat the same step. What are you going to get? Give me one more minute, ya shabab, okay? You will get MAL plus RA L square over 2, which is equals to W0 A cube over 6 minus W0 A square L over 2 plus W0 A L square over 2. And this is equation number 2. Now, you got two equations with two unknowns. Two equations. الإكويشن اللي قبل فيها MA and RA. هذا رقم واحد. رقم اثنين فيها MA و RA. So what can you do? You can solve for RA. You can solve for MA. إذا حليت two unknowns, RA and MA are known. ترجع إلى المعادلة الرئيسية هنا. ترجع إلى هنا. الآن when you come back to this one, okay, what happened? This is known, this is known. These two are unknown. Sum the forces along Y, sum the moment. You will have two equations, two unknowns. You will solve the problem. Understood, ya shabab? What I'm going to do today, I'm going to upload the solution, the slide with the solution for you. I advise you to go and solve it by yourself. Your hand will be shaky a little bit with the integration, but once you do it, it will stick in your mind. Okay, Shabab? Thank you so much. See you next class. I already posted the announcement, Shabab. to delay the quiz based on the survey that you did. Okay.